Welcome back. In this video we'll be talking about logarithms. So let's motivate why we need logarithms. Something we have a lot of practice with is solving for x. If we want to solve an equation like 6 is equal to x cubed for x, we're used to applying the cube root function to both sides. Applying the cube root to both sides gives us the cubed root of 6 is equal to the cubed root of x cubed, which is equal to x. The reason why we can say the cubed root of x cubed is equal to x is because the cubed root function is the inverse function to the cube function. That is, writing down y is equal to x cubed is equivalent to writing down x is equal to the cubed root of y. But now what happens if we have an equation like 6 is equal to 3 to the x? How do we solve that for x? To use the same technique as above, we need the inverse function for the exponential function 3 to a power, and that's where the logarithm comes in. The inverse of an exponential function is called a logarithmic function, and we write log base b as the logarithmic function that is the inverse function for b to a power. So if we want to solve 6 is equal to 3 to the x, we apply log base 3 to both sides of that equation. Then log base 3 of 3 to the x is equal to x, because those are inverse functions. And so we can write that x is equal to log base 3 of 6. That's the answer to what is x if 6 is equal to 3 to the x. And so just like here when we said that y is equal to x cubed is equivalent to x is equal to the cube root of y, we also have that if y is equal to 3 to the x, then that's equivalent to x is equal to log base 3 of y. And this expression works for all bases b. Y is equal to b to the x is equivalent to saying x is equal to log base b of y. And what this lets you do is it allows you to convert between expressions involving logarithms and expressions involving exponentials. So if you're asked to evaluate log base b of y, that's the same as answering b to what power is y. So for example, if we're asked to evaluate log base 5 of 125, that's the same as answering the question 5 to what power equals 125. We know that 5 times 5 times 5 is equal to 125, and so x is equal to 3, because 5 cubed is equal to 125. And so log base 5 of 125 is equal to 3, because 5 to the third power is equal to 125. Here's another example. Evaluate log base 10 of 100. That's the same as answering 10 to what power is 100. We know that 10 squared is equal to 100. So log base 10 of 100 is equal to 2. What about log base 7 of 1? 7 to what power is 1? Here, 7 to the 0th power is equal to 1. So log base 7 of 1 is equal to 0. What about log base 2 of 1 over 128? We're answering 2 to what power is 1 over 128? As computer scientists, you'll quickly have experience with powers of 2 and know that 2 to the 7th power is 128. So 1 over 128th is 1 over 2 to the 7th, and we know that 1 over 2 to the 7th is 2 to the negative 7. So when we need to figure out 2 to what power is 2 to the negative 7, log base 2 of 1 over 128 is equal to negative 7. Here's two more examples. Log base 6 of 0 and log base 13 of negative 42. In this first example, 6 to what power is equal to 0? We recognize that we can't really put anything into the exponent and get 0. And so this is undefined. Similarly, if we wanted to put 13 to some power and get negative 42, that's also undefined. A power of a positive number can never be negative. And so that leads us to our first rule of logarithms, that log base b of y is undefined if y is less than or equal to 0. Because we know that the exponential function base b and the logarithm base b are inverse functions, we have that log base b of b to the x is equal to x, and we have that b to the log base b of x is equal to x. Some other special cases are that log base b of b, or log base b of b to the 1, is equal to 1, and log base b of 1, which is log base b of b to the 0, is equal to 0. Those are both true no matter what base b we're dealing with. So for example, log base 42 of 42 is equal to 1, and log base 42 of 1 is equal to 0. Here's an important rule of logarithms. Log sub b of x times y is equal to log sub b of x plus log sub b of y. Now why should that be true? What we're saying here is that log base 10 of 10 squared times 10 cubed is equal to log base 10 of 10 squared plus log base 10 of 10 cubed. Hey wait, this first one is log base 10 of 10 to the 5th, and what power of 10 gives 10 to the 5th? 5. Similarly, log base 10 of 10 squared is 2, log base 10 of 10 cubed is equal to 3. Hey wait, this 5 is equal to 2 plus 3. That makes a lot of sense. A related equation is that the log base b of x over y is equal to log base b of x minus log base b of y. But unfortunately, if you see something like log of b of x plus y, it doesn't simplify directly. You may actually have to go in and add those two numbers together, but in general, the log of a sum doesn't have a nice simplification. So now let's investigate a generalization of this rule here. If we take the log of a power of x, we can bring the power down out front. So log base b of x to the c is equal to c times log base b of x. How is that related to the rule above? If we look at log base b of x times x times x, this rule tells us we can add those logs. Log base b of x plus log base b of x plus log base b of x. That's 3 copies of log base b of x. And so we brought this exponent, x cubed, as a coefficient of log base b of x. Let's stop there for now. See you later.